What's up, Algebra 2 students? Mr. Messner here. Let's do the review, okay? Now, I love this unit. Very much builds upon itself. You got to know kind of day one to do day two and day three. If you know day two and day three, you can handle day four no problem. All right. So, in every single lesson, day one, two, three, four, we are expected to simplify square roots, okay? Here's what you need to do. Step one, for all of these problems, like I'll do number one and number five at the same time. For all these problems, can you take the square root of the number? Oh, yes, I can. I'm done. The square root of 36 is just 6. These are one of the greatest, these are one of the perfect squares. There's only a few numbers that are called perfect squares. And perfect squares are important, and we're going to have them listed up, for you guys to help you. The square root of 4 is 2, because 2 squared is 4. The square root of 9 is 3, because 3 squared is 9. Next one is 16, because 4 squared is 16. The next one is 25, 5 squared. The next one, 36, 6 squared. 7 squared, 49. 8 squared, 64. And these are all numbers you could figure out yourself. And they keep going. They don't stop there. I'm going to stop there, but they keep going. So look, the square root of 36 is 6. This will be up on the board. Okay, this will be given to you, at least in my class, I think in the other classes. Now let's try the other one. If you can't, take the square root. Here's what we are asked to do. Simplify the square root. Okay, we are going to pay attention to the top row. Almost forget about the bottom row. Almost pretend it's right. It's not even there. Pay attention to the top row. Which one of these numbers, don't worry about the square root right now, just the number, goes into the number 75? So, advice is, and it's not which one of these, it's which one is the biggest, which is very important for some of them. Advice is to start big and go to the small ones. So try to divide by 49. Try to divide by 36. Try to divide by 25. Okay, I know it's not going to be 64 or 81. 64 is already bigger than half. I know it's not 81, it's bigger. So 25 is the biggest perfect square. Now what does this mean? 25 times 3 is 75. Okay? That means root 75 is root 25 times root 3. Why do we do this? Because the square root of 25 is 5. 5. Too many students say, oh, great, root 25 turns into root 5. Don't do that. The square root of 25 is just 5. Your calculator can help you. What's the square root of 25? Just the number 5. What's the square root of 3? This crazy decimal. Can you simplify the square root of 3? No. So you are done 5 root 3. So that's what we're doing. Step 1, can you take the square root of the number? There are going to be some questions where simplification's easy because the square root of the number is just a whole number. The square root of 81 is 9. But then there's going to be some questions, we're going to go to number 6, where it's not so easy. I try to take the square root of 112, and I can't. Okay, so I start taking 112 and dividing it by big perfect squares like 81. Let's try 64. Let's try 49. Let's try 36. Let's try 25. Let's try 16. Oh, okay. 16 times 7 is 112. Root 16 times root 7 is root 112. The square root of 16 is 4. These numbers show up after you're taking square roots of them. The square root of 16 is 4. The square root of 7, I have no idea what it is. It's this decimal. There are no number that can be divided into 7 so that we can simplify 7. So 4 is the square root of 16. We keep the square root of 7. Okay? Let's do 3 then 7. 3. Always try this. What is the square root of the number? Oh, look at that. This is a perfect square. So the answer of the square root of 121 is just 11. 11 times 11 is 121. 11 squared is 121. Boom. Now, notice we don't have a plus or minus here because we're not solving an equation. When we solve equations, we need plus or minus. It's just kind of how we show there being two solutions to these quadratics equal to 0. But if I'm asked to just simplify a square root, we don't. Now, let's look at this. This one confuses some students. Okay, all I can tell you is just let's pretend the 4 is not there. Let's just move it off to the side and just be like, yo, it's there, but let's just focus on the square root of 63. Can you take the square root of 63? No. Okay. Focus on the numbers inside these square roots. Can you divide 63 by any of these numbers? Let's start with 36. Nope. Can you divide it by 25? Nope. Can you divide it by 16? Nope. Can you divide it by 9? Yes. Again, we see 9 times 7 is 63. 9 times 7 is 63. So root 9, root 7 is root 63. The square root of 9 is 3. Use your calculator to check. The 4 is still there, so you have 3 root 7, right? But the 4 is still there. What is the 4 doing? It's being multiplied by root 63. So that means you'd multiply it by 3 root 7. Now, don't multiply these nice whole numbers by the root. It doesn't work out nicely, but you can multiply the 4 and the 3 together. One great thing to do for all of these is to double check. For example, for number 6, the square root of 112 is the same as 4 times the square root of 7. 4 square root 63 should be the same as 12 times the square root of 7. Okay? That's me checking. All right, next one. Can I take the square root of 27? No. All right. Focus on the numbers inside the square roots. Can we divide 27 by 16? No. Can we divide 27 by 9? Yes. 9 times 3 is 27. Root 9 times root 3 is root 27. The square root of 9 is 3. The square root of 9 is 3. 3 root 3 is my simplified answer, and we could check to make sure I did it right. And then 7 root 20. The 7's still there. I can't take the square root of 20. I can take 20 and divide it by 4. 4 is one of my perfect squares. Right there. Keep that list with you. I might rewrite it, but I might not. 4 times 5 is 20. Root 4, root 5 is root 20. The square root of 4 is just 2. 7 times 2 is 14. Okay. 2 root 128. And then we got these. Now, this shows up in the quadratic formula. So all we're going to do for 10 and 11 is just practice doing this part of the quadratic formula. Square root of 128. Can I take the square root of 128? Nope. Okay. Are any of these numbers, do they go nicely into 128? Let's see. Let's try 81. Let's try 64. Ooh, 64. 64 times 2 is 128. 64 times 2 is 128. So root 64 times root 2 is root 128. This 2 is still there. The square root of 64 is just 8. So this is 2 times 8 times root 2. I can multiply 2 and 8 together. And I get 16. 16 root 2 is the same as 2 root 128. Okay. All right. Now, here's the key. This is the quadratic formula. We're giving you what A, B, and C is. For using the quadratic formula, you have to identify what it is. Use parentheses, guys. Parentheses, parentheses, parentheses. Super important. Now, here's what we got to do. I'm going to pretend like the square root's not even there. Let's pretend the square root's not there. Let's figure out what's inside the square root. So I got negative 3 squared minus 4 times 2 times negative 5. Not even going to worry about the square root until the very end. Okay? Now, this is where my calculator comes out. And I have negative 3. This is in parentheses. Don't make the mistake of not using parentheses, because if you don't use parentheses, you're not going to get the right answer. If you use parentheses, you are correctly told that negative 3 squared is 9. If you don't use parentheses, you get negative 9. That's wrong. Negative 3 squared is positive 9. So you have to use parentheses. So I got negative 3 squared minus 4 times 2 times negative 5. And I get 49. This is 49. But the answer is not 49. The answer is the square root of 49. What do we do now? Oh, can I take the square root of 49? Yes, I can. The square root of 49 is just 7. My answer here is just 7. And this would be multiplied or divided by 2a in the quadratic formula. Let's do this one. Just worry about what's inside the parentheses first. B squared minus 4ac. Using parentheses, 8 squared minus 4 times 1 times 9 is 28. But I need a root 28. Can I take the square root of 28? No. Can I divide 28 by some of our perfect squares in the stars? That's what you're going to try. So you try 9. No. You try 16. No. I mean, you should be trying just 9 or 4. You know 16 is not going to work because it's already above half. Okay. 4 times 7 is 28. Root 4. Root 7 is root 28. 2 root 7 is root 28. This would be my simplified square root of b squared minus 4ac. All right, moving on. Now we're going to go back to what we did last unit, and we're going to solve these quadratic equations. Last unit, we would solve this equation by factoring. This ends up being x plus 4, x minus 4 equals 0. This is the whole difference of squares, or DOS. Your answers are negative 4 and positive 4. Okay, so that's what I'm expecting to get. I'm going to get the same answers a different way by using square roots. Now, the square root method is isolate the square and then square root both sides. So step 1, isolate the square by getting it by itself using algebra. Square root both sides. Don't forget a plus or minus because we're using a square root to solve. We know there's two solutions here, positive and negative 4. How do we get those two solutions? Well, I'm going to add 16 to both sides. I get x squared equals positive 16. The square is isolated. I now square root both sides. And I get x equals, okay, this is where we go back to doing a little bit of work. Can we take the square root of 16? Oh, yeah, it's 4. But my answer is not just x equals 4. I'm using a square root. I need a plus or minus, positive and negative 4. That's how we get those same solutions that we would have gotten if we factored. Isolating the square sometimes means, adding and then dividing. Square root both sides. Now, we talked about how if you square root a fraction, it's the square root of the top over the square root of the bottom. And the square root of 1 is 1, and the square root of 9 is 3. But watch this. The square root of 1/9, you can use division, you can use the fraction button, is 0.333. If you have one of the yellow calculators, use that arrow thing. Or if you have this calculator, math enter. 1/3. It's like it giving you 1/3. But don't forget the plus or minus. I should kind of put this down here. X equals positive or negative 1/3. This would be the exact same thing as if we factored this difference of squares 3x minus 1, 3x plus 1. You'd get 1/3 when you set these two equations equal to 0. Okay, it's the same thing here. Like we might have to do a little bit of work to isolate the square, but this is just using algebra. I added 324 to undo the subtraction. I divided to undo the multiplication. 324 divided by 4 is 81. Can I take the square root of 81? I can. If I couldn't, I would look to simplify. Okay, I get 9. That's the square root of 81. But we get plus or minus 9. All right. Now, the next ones we remember from 2 units ago, vertex form. Y equals a, x minus h squared plus k. The vertex is always going to be at h comma k. And it's always going to be like the opposite of what you think it will be for the x. So like the vertex for this one, the k is negative 16. The h is positive 3 because it's x minus h and the vertex is 8. So it's like ends up being opposite. We shift to the right here. Okay. Now to find my solutions, how do you find the solutions? The solutions to the quadratic equation are when your quadratic equation equals 0, when y is 0. Now you can have it set up like this, or you could have it set up like that, where it's equal to 0 on the right side. I find students just are more comfortable when it's equal to 0 on the right side, but don't let it freak you out. You're going to do the same thing no matter what. So I'm going to do that. I'm going to set the equation equal to 0 on the right side. It's just like when y is 0. And I'm going to isolate the square, undo the subtraction. And here I can see I have these parentheses being squared. That's an isolated square. You don't try to simplify this. You don't square x minus 3 because most of you will probably do it incorrectly. Now is the time to square root the square. They are arch enemies. They will die in battle together. All right, so I leave x minus 3 on this left side. Now on the right side, I need to simplify the square root of 16. Well, the square root of 16, it's just the number 4. But I'm using a square root to solve a quadratic equation. We know quadratics usually have 2 solutions where they cross the x-axis, sometimes just 1. That means I need a plus or minus 4. Okay? Always use a plus or minus when you're isolating. Finish things off by adding 3, because that's how you undo this minus 3. Now notice the minus sign moves down, the x minus 3 moves down, keep things very neat and orderly. I add 3 to both sides, giving me 3 plus 4 and 3 minus 4. Now you could do this in your calculator right now. 3 plus 4, 3 minus 4. What you don't want to do is say plus and minus 3. Like you're not adding and subtracting 3. You're just adding 3 to positive and negative 4. So we get x equals 7 and x equals negative 1. You could have also done positive 4 plus 3 and negative 4 plus 3. That also gives you the two answers, but we like to have it in this form. Okay, vertex and solutions for the next one. The vertex will be at negative 4, negative 4. How do I know that? H is negative 4 because it's plus 4. K is negative 4. Let's find my solutions. I'll start by adding 4 to both sides. I'll then divide both sides by 4 to isolate the square. The square is isolated. I'm ready to square root both sides. The left side, the parentheses, the square, and the square root will go away, leaving me with just x plus 4. On the right side, I need to simplify this. Okay, well, always try to find the square root of what you see first. Oh, the square root of 1 is 1. That means 1 times 1 is 1. 1 squared is 1. I use the square root to solve. Always include a plus or minus. I finish things off by subtracting 4. Now, when I subtract 4, how it's going to look in the standard form is negative 4 plus 1 and negative 4 minus 1. I know we're subtracting 4, but know that subtracting 4 is the same as adding negative 4. I got to write a little bit smaller here. So the vertex was at negative 4, negative 4. And here are my solutions. Negative 4 plus 1 and negative 4 minus 1. X equals negative 3 and x equals negative 5. What's cool about this, and it kind of shows you the quadratic formula right here. What do we notice? Like the vertex is in the middle, 3. 7 is a distance away, like 4 away. Like look at where the 3 shows up. Yeah, the 3 should always be here. It's the x coordinate of the vertex. It's like where we start. Okay. And then we add a distance. We add 4 to get to that 7. That's getting to our first one. And since a quadratic is symmetrical, you subtract the same distance and you get there. So notice like x coordinate of the vertex should be this number right here. And then we add and subtract this like distance to get to your solutions. It's really neat and it's beautiful display of the symmetry of quadratics. If your vertex is in the middle, the solutions have to be the same distance away from each other. All right, here the vertex is negative 2, negative 18. Now, that means my solution is going to be like to the right and to the left of negative 2. So like maybe it's negative 1, negative 3. Maybe it's 0 and 4. But it has to be this 0 and negative 4. But it has to be the same distance away. Now, it might also be a number that is a decimal. Maybe it's like negative 2 plus root 2 and minus root 2. So we're just ready for everything. Okay, square root gets rid of the square. I have x plus 2 equals. Can I take the square root of 9? Yes, it's just 3. But it's both positive and negative 3 because I'm using a square root to solve an equation. I then will add negative 2 to both sides or subtract 2 to both sides. You cannot subtract 2 from this 3 and make it plus or minus 1. That doesn't work because it's just negative 2 plus 3 and negative 2 minus 3. Use your calculator to help you. This is the distance away from your solution. So there's your vertex. Take that vertex, negative 2. It's what we expected. Plus 3 and negative 2 minus 3. 1 and negative 5. Makes a lot of sense and it's beautiful to see. They're 3 away from negative 2. Let's keep going. Here I'm going to add 75 to both sides. I'm not going to ask you what the vertex is for this one. We never talked about having something inside this parentheses with like it's a bx. Um, it's going to be at like 3/2. You'll see. But I didn't expect you to do that. So we're not going to skip. We're going to skip the vertex for this one. We're just going to focus on the solutions. All right, we're going to divide 75 by 3. You can use your calculator to do this. You get 25. Square root both sides. Can I square root 25? I sure can. The square is isolated. We get rid of the square. We square root both sides. On the right side, I have plus or minus 5. On the left side, I have 2x minus 3. Now watch what happens here, and you hadn't seen this in the notes, so this is a little bit of a challenge. How would you get x by itself? Okay, you would add 3, giving you 2x equals 3 plus or minus 5. And then you would divide by 2. Now this gives you x equals 3 over 2 plus or minus 5 over 2. Now that's fine. That's the right answer. We haven't seen it, but like we've seen answers like this where? In the quadratic formula. So we're not going to be too shy about that. We're not going to be too intimidated by it. After we do the addition and subtraction, we get 4 and -1. And we expect you to simplify that to be like 2 numbers, okay? Here, let's subtract 60 from both sides. Let's divide by -3 on both sides to isolate the square, and I get positive 20. Great example where if we square root, it doesn't work. What's the square root of 20? Sorry, I can't do the square root of 20. Oh, what do I do now? Simplify like we did 1, 2, 3, 4, 5, 6, 7, 8, 9. What number goes, what perfect square goes into 20? Well, check 9. Obviously, that's not going to work. Check 4. Yeah, 4 times 5 is 20. Root 4, root 5 is root 20. 2 is the square root of 4. The square root of 5 cannot be simplified. Square root of 4 is 2. The square root of 5 cannot be simplified. So we end up with 2 root 5. This is a plus or minus because I square rooted to solve an equation. Over here, after destroying each other, you have x minus 1. I see a lot of my students have that equal sign disappear in between. Don't let it disappear on you. Show every step. Now we finish off by adding 1. But guess what, guys? We're done right here because you are not allowed to add 2 root 5 to 1 and get like 3 root 5. That's not true. You'd have to add root 5s to root 5, similar to you add like x's to x's. So we're done with that. That's the answer. This is how you're going to have it on your test, and it'll be accepted. 1 plus 2 root 5, 1 minus 2 root 5. We do expect you to simplify to get simplified whole numbers, okay, if you have a number plus or minus another number. This is really the same. Let's just be ready to simplify numbers other than 20. Because the square root of 20, we just talked about it. It's 2 root 5. Plus or minus, because I'm using a square root to solve a square. Add 3 to both sides. Add 3 to both sides. 3 plus or minus 2 root 5. Quadratic formula. Uh, Up to you which form you use. There's two different ways. Okay, it's either like simplified first or simplified at the end. Um, Here's what we got to do. It's very simple, and again, this is how we use a square root to solve standard form. Now, a standard form is ax squared plus bx plus c equals 0. Yo, a, b, and c are numbers. They're the number that comes before x squared. They're the number that comes before x. It's the number left by itself. And smart mathematicians solved this using square roots in a very cool way, and they realized that they could make a formula out of it. And here's the formula. Now, what do you notice about the formula? Oh, it's got a plus or minus. Yeah, because we're solving quadratics using square roots. You need the plus or minus when you use a square root to solve. Okay, so this is just another method of using square roots to solve quadratics. Here's what you got to do. Identify the number A, the number B, and the number C. Use parentheses to plug in. Okay, here we go. X equals, I got negative B. You can use parentheses around that. So that's negative 8 over 2 times A. Now I'm going to go ahead and just simplify that, and I get negative 4. All right, cool. Now on the other side, do you remember the square root of B squared of minus 4AC? Let's pretend the square root's not there. Don't do the square root yet. Let's do B squared minus 4AC first. Pay attention to details. There's a lot of kind of number calculations that we're doing here that a lot of students make mistakes at. So I got 8 squared minus 4 times 1 times negative 2. Okay, that's 72. You might as well have done that over on the side, honestly. Like B squared minus 4AC. Do that on the side. B squared minus 4AC. And you got 72. 72 goes here, and it goes underneath the square root. But we are dividing that number by 2 times A. Now, what's important? You cannot divide 72 by 2. You need to simplify the 72. So honestly, let's just keep working with the fact that this is the square root of 72. Let's just keep going down. Okay, can I take the square root of 72? No. Can 72 be divided by a perfect square? Yes, this is the questions 1 through 12. Okay, go back to that perfect square list or write them down again. 64, 49, 36. 36 times 2 is 72. You'll see 72 a lot because it's a tricky one. Root 36, root 2 is root 72. The square root of 36, 36 times 2 is 72. Root 36 times root 2 is 72. The square root of 36 is just 6. The square root of 2 is not nice. It's a decimal. 6 root 2 is the simplified that. I literally just worked with this over here, and I got that. That's the top part of my fraction. Do that first. Because then you can simplify. Like you did 8 divided by negative 2, and you got negative 4. You can do 6 root 2 divided by 2. Now, this is how it works. Let's pretend the root 2 is not there. Can you simplify 6 over 2? Use your calculator maybe, or divide the top and bottom by 2. 6 divided by 2 is 3. My answer is negative 4 plus or minus 3 root 2. And I'm done. Okay? I like doing this. Work with this part, which we did earlier in the review first. Okay, and I'm going to do this one using this method. Okay, so I got x equals, let's identify a, b is -8, c is 7. X equals negative b, so that's negative b. See how we use parentheses around b? Well, that's the opposite of b. This turns into +8. Okay, plus or minus. Let's work with everything and let's worry about it at the end. Okay, I'm not going to plug it into the formula because everybody messes it up. B squared minus 4ac. Just so you don't freak out. 8. That 8 is under the square root. What's the square root of 8? Can't do it. Can you take 8 and divide it by a perfect square like 4? Yes. 4 times 2 is 8. Root 4 root 2 is root 8. 2 root 2 is root 8. Up here is 2 root 2. This is divided by 2 times a. All right. If you did it this way, you get +8 plus or minus 2 root 2 over 4. Now, the last step, and this is the simplify at the end, is to divide both of these by 4. So I got 8 divided by 4. That's 2. And I have 2 divided by 4. That's 1/2. You could put 0.5, I don't care, or you can put 1/2. So this turns into 2 plus or minus 1/2 root 2. I'm okay with that. That's the same as root 2 over 2. I'm okay with that. Just figure it out. Heads up, if you ever see a quadratic, but not everything's on the same side, everything needs to be on the same side. So, do what's easiest. Sometimes it's easiest to just move the right side to the left side. Sometimes it's easiest to move the left side to the right side. It doesn't matter. Okay? Here, what would I do? I'd subtract the 2x, but I'd make sure I'd write it in what's called standard form, x squared minus 2x minus 4. That equals 0. Here, if you want to, you could subtract the 9x squared. Make that easy on yourself. I'll do that because I've seen some people do that. Okay? Now, here we go. A is 3, B is -5, C is -1. Opposite of B over 2 times A, plus or minus. All right, let's figure this out. B squared minus 4AC. Use your calculator. This is the inside of the square root. B squared minus 4 times A times C. 37. Yep. But I'm taking the square root of 37. Can I take the square root of 37? No. Can the number 37 be divided by another perfect square? Like 25, 16, 9, or 4? No. Root 37 is perfectly simplified. So that's what goes right here. 2 times A goes in the bottom. 2 times A, might as well do this all at once and make that a 6. Do not divide this 6 into a root. That's a whole number. You can divide it by another whole number, which we don't have. So we're done. This would be the location of the vertex, the x location. This would be how far we would have to travel to get to our solutions. All right. A is A is 1. B is -2. C is -4. Let's do B squared minus 4AC first. Use your calculator. Move up a little bit. -2 squared minus 4 times A times C. 20. That is B squared minus 4AC. That's what goes under the square root. Can you take the square root of 20? No. Can you simplify the square root of 20? Well, 20 can be divided by 9. No. Can it be divided by 16? Oops. 20 divided by 16? No. Can I divide it by 4? It should be going from top down. Yes. 4 times 5 is 20. Root 4 times root 5 is root 20. 2 root 5 is root 20. Here we go. X equals opposite of B over 2 times A plus or minus, this is what goes up top, over 2 times A. 2 times A is just 2, so you might as well put 2 times A down there, and then that's just 2. Divide 2 by 2, you get 1. Divide 2 root 5 by 2, or just divide 2 by 2. The numbers can be divided. Don't divide by the roots. You get root 5. You're done. You cannot simplify this whole number in that root. Okay? See, I like doing it this way. This is so much easier. Okay, x equals, let's go A, -9, B, -12, C, -4. Let's work on opposite of B over 2 times A. What's 2 times A? 2 times -9 is -18. Just leave that. Okay, on the right side, let's figure out what B squared minus 4 times A times C is. -12, this is all in parentheses, squared, minus 4 times -9 times -4. 0. Beautiful. That's what goes under the square root. What's the square root of 0? 0. Which means 0 goes here, divided by -18. Now let's simplify. What's 12 divided by -18? Math, enter. You can divide the top and bottom by 6. -2/3. What's 0 divided by -18? 0. What's -2/3 plus 0? -2/3. What's -2/3 minus 0? -2/3. So your answer is just -2/3. This is when your solution is the vertex. Vertex is your solution. Remember when we graph these quadratics and sometimes they would just like go pink like that? That's this situation. Okay. We move into day 4 and all of a sudden we have these square roots of these negatives. And we freak out because I am not allowed to take the square root of a negative. It's not real. That's because it's imaginary. You can't do it, but it is a solution. And here we go. All we need to do is realize that whenever you have the square root of a negative, It's an imaginary number. Now we want to simplify the square root so we know like quantities of the imaginary numbers. Um, and here's how I do it, though. You could just be like, yo, pretend it's positive and I know I have an I at the end. But I say, well, the square root of -1 is I. Like this is the definition of what it means to be an imaginary. If you are a negative, you are imaginary. You can't do it with a calculator. It's more of an idea rather than an actual number. It is something that can solve things, and it's used in more advanced mathematics to show things that are occurring in the world, in the universe. But for you guys, just knowing that it exists and that it can be used is all you need to do. I do root 16, root -1, because, right, 16 times -1 is -16. The root of -1 is I. Can I simplify the root of 16? Well, this is when we simplify again. This is why I love this unit, because it really builds upon itself. Could you do day 1? Well, you could do day 4. Can you do day 1, day 2, day 3? You can do all of day 4. Just you're going to have answers with i's. Here's 4i. That is the simplified square root of -1. It is a concept. It is not a number. 4i's could be a solution to an equation. Try the square root of 108. Again, I will try to write this as root 108, root -1. All right. Now, let's remember our perfect squares, because we can simplify this to be like combinations of numbers and roots and i's. So go back to our perfect squared chart. These are the numbers that are important. These are the results. Root 4 is 2. Root 9 is 3. Root 16 is 4. Root 25 is 5. Root 36 is 6. Root 49 is 7. Root 64 is 8. Root 81 is 9. And it keeps going. Okay? We usually don't have to worry about anything beyond that. Take the numbers. 108. Let's start dividing by numbers like 64, 49, 36. All right, 36 times 3 is 108. Root 36, root 3 is root -108 times root -1. Root 36 is 6. The square root of 36 is 6. The square root of 3 is the square root of 3. The square root of -1 is I. This does not simplify. It's an ugly decimal. You type this into your calculator, you get 6. Got it? All right, root 45, root -1. Can I take the square root of 45? That's always what we try first. No. Can 45 be divided by 25? 16. 9. Yes. 9 times 5 is 45. Root 9, root 5 is root 45. 3 root 5i is the same as square root of -45. The last 4 guys, I'm going to say, hey, what method's going to work best? Use it. I'm not telling you to use square roots. I'm not telling you to use a quadratic formula. You should just know, like, if you have vertex form, which is 29 and 30, you should be using square roots by isolating the square roots, kind of. If you have standard form, ax squared plus bx plus c, quadratic formula, which also use square roots and pluses and minuses. You know, it's like the same. It's just different how you do it. Okay. So what do? Square roots, isolate the square. This time I'm subtracting 25 because it's plus 25. The square is isolated. Square root, both sides. The square and the square root will undo each other. They're gone. It leaves you with x minus 1. Do what you just did up above. What is root 25? Root negative 25. It's root 25, root negative 1. Can you take the square root of 25? Should always be your first thing to do. Yes, it's 5. 5 times I is what we call the square root of negative 25. But since we are solving an equation using a square root, I need a plus or minus. I don't up above because I'm just asked to simplify. Like the square root of 9 is 3. But if I say x squared equals 9, what are the solutions? The solutions are positive and negative 3, even though I use a square root of 9. Okay? Let me just say that again. The square root of 9 is just 3. But if I say x squared equals 9, your solutions are x equals plus or minus 3, even though to get there, you're square rooting 9. It's the whole like this is plus or minus x. Got it? All right. Finish things off. How do you get rid of the minus 1? You add 1. This is just algebra, guys. It's just algebra. Don't forget about your rules. Let's do this one. Isolate the square. Well, I'm going to subtract the 30 first. And look at me writing out every step. I'm going to divide by 3 second. And I get negative 10. I square root both sides. The square root and the square undo each other, leaves us with just x plus 3. What is the square root of negative 10? Don't try to type it in. Your calculator is going to be like, error, error, error. That doesn't mean like stuff's wrong. It just means, oh, your answers are imaginary. So what you do type in is like, what is the square root of positive 10? Okay, I can't do that. Can we simplify the square root of 10? Can we divide 10 by 9, by 4? No. So this is just root 10 I. It's root 10 root negative 1. That's it. This is it. This is the simplified one. It's a plus or minus, and I get rid of the 3 by subtracting 3. This is the answer. Negative 3 plus or minus root 10 I. All right, let's use the quadratic formula for the last ones. This should be a equals 0 on the right side. You could actually divide everything by 2 and make it easier on yourself if you wanted to. But let's pretend we're not. All right. A is 1. B is 6. C is 10. X equals opposite of B over 2 times A is 2. Plus or minus. Let's work on the inside. B squared minus 4AC. 6 squared minus 4 times 1 times 10 is negative 4. Negative 4 is what's under the square root in the quadratic formula. The square root of negative 4 is the square root of 4 and the square root of negative 1. The square root of 4 is just 2. The square root of negative 1 is I. 2i is what ends up here on the top. But that's divided by 2a, again, which is 2. Now do some division. Negative 6 divided by 2 is negative 3. Use your calculator if you need it to. Divide the numbers by the numbers. 2 divided by 2 is just 1. So you get negative 3 plus or minus I. Okay? Let's do it one last time, and then we're done. A is 2, B is 8, C is 10. X equals the opposite of B over 2 times A. Plus or minus. Let's figure out B squared minus 4AC. Using your calculator. Parentheses. B squared minus 4ac negative 16. Can you simplify that? Yes. Well, that's what's under the root. Root 16, root negative 1. Can you take the square root of 16? Yeah, it's 4. It's just 4. So this is 4i. That's what goes on the top. The bottom is 2 times a. Don't even write, just write it. What is 2 times a? What is 2 times a? 4. 4. Divide. Using your calculator, negative 8 divided by 4 and 4 divided by 4. Or you know that negative 8 divided by 4 is negative 2. And you know 4 divided by 4 is 1. This is your answer. These are your answers. Now, be ready on the quadratic formula to get something like that, where you simplify and you have root something I, or 4 root 3i, and then you can divide the 4 by the number. But hopefully, since this is very much like a lot of the same stuff, repeated, you're going to be okay. All right? Hopefully, you're going to be okay. There you go. There's a video. Mr. Messner, out.